Good morning, my name is Scanzio, and in this video I will present TSCHmodeler, which is a discrete event simulator for TSCH networks. TSCH is a protocol for wireless sensor network that has some interesting characteristics. The first is that the transmission can be scheduled in time using a technique similar to TDMA, and at the same time it implements channel hopping that can have obtain a good quality of communication even if some transmission channels are noisy. To download the simulator, you can directly go on the TSCHmodeler website. You can type the name of the simulator, TSCHmodeler, and you will be redirected on this project, on which at the end here you can find this zip file that contains the whole simulator. Okay, I downloaded the simulator in this folder. You can open it with the preferred editor. In my case, I use Visual Studio Code. And you see here in the directory that you have some files. TSCHmodeler is open source. In particular, this one is the main that loads the configuration and all the needed environment. Then we have this file that is named generator, and the generator class is the class that is devoted to create new class packets. So if we start from this network, that is a network that I will show you in this example, you see that in this case packets are periodic. They are generated with this period. This period is in terms of time slot, so in the simulator all the simulations are performed in terms of time slot, where a slot has a length of 20 milliseconds. You see that packets are generated periodically, and in this case are generated directly to the root, and this is the topology of our network. Then we have the node class that is the network node for transmission that takes tracks on some characteristics, for instance the number of transmitted packets in order to log power consumption. Then packet class is the packet that is generated by the source node and it is destroyed on the destination node, and take tracks of the statistics related to packets, for instance how much it is retransmitted, the waiting time inside the node, the latency, and so on. We have a logger class that performs for us the most important logging, and finally we have this TSCH class that is the main part of the simulator, on which we simulate the transfer of packets from one node to another node when this transfer is possible, so when there is a scheduled transmission between these two nodes. The conf directory contains a set of configuration. For instance, in this configuration related to this topology I showed to you, you see that there is the configuration of the duration of the simulation. We have 1 year. I decrease a little bit to be faster. The dimension of the slot frame matrix, that is 101 slots that correspond more or less to 2 seconds, because the schedule of TSCH repeats over time. Maximum number of retransmission. Then a link to another configuration file that I will show you, and contains the configuration of the matrix where to place the result. Here we have the flow. In our case, the flow are produced by the leaves and arrive to the root node. So for instance, for this source node 1, there is a flow that has destination node 40, that is this one. The flow is periodic with this period in terms of slot. You will see that is about 1 packet every minute, and here you have the routing. So To write to the destination, this flow must pass node 28, this one, node 27, and node 40. We use the generation period as coprime number in order to have this flow that mix together and provide more reliable results. In this other folder we have the configuration of TSCH matrix. We have the offset that represents in which position of the matrix this scheduler set is located. We have the channel offset that is like a virtual channel. Here we have all 0, but you can differentiate in order to possibly perform the transmission on 2 different channels at the same time. So the real channel is changed at every transmission for the channel hopping feature of TSCH. Here is say that this transmission is scheduled for from node 35 to node 39. And here we have the channel model that is really simple, but basically since in TSCH on the 2.4 GHz band we have 16 channel, we have the frame delivery probability 75% for data packet and the frame delivery probability in this case 100% for ACK packet for every channel, channel 1, channel 2, channel 3, and so on and so forth. If we want to run our simulator, since TSCHmodeler is in Python, we can here I'm using Linux, but in Windows or Mac OS call the simulator, then we can pass the configuration file, for instance the one I showed you before, this one, and you see that the simulator run provide at the end some statistics about power consumption and reports the number of events and the simulation time. If we analyze more in details the output of this simulation, you see that at the beginning there is the loading of the configuration, then at this time there are the simulation events. We have an events for every beginning of the time slot that are configured on this TSCH slot frame matrix. Okay, sometimes I have a packet to transmit, sometimes, like in this case, there is a possible transmission between node 35 to node 39, but this possible transmission is never used because there are no packet in queue on the node. After some times, so after a little bit more than 3000 slots, there are the packets that start to be enqueued inside the node. You see this is the first packet that is queued on node 1, and this packet must flow from node 1 to node 40. Here we have the queuing time, and here the node that has to pass to arrive to destination. We are the queuing of other packet. We arrive on this position on which we have the transmission of a packet. So at this time is an absolute number that is increased every 20 milliseconds, so every dimension of slot. There is a transmission between this packet from node 6 to node 29, but since the data was lost, because remember that we have the 75% of probability that the data is lost, the packet is not moved. For sure, in some situation, the packets can arrive to the destination, like in this case. So in this case, this packet was moved from node 5 to node 40, and since it arrives to destination, you see that there is the queue event that removes the packet from the queue of node 5 and in queue the packet at the same time on queue 29 of node 29. At the end of the simulator, sorry, I need to run the simulation. At the end of the simulation, there is the production of these log files that you see that for every packet logs some information. For instance, it logs that this packet is from node 1 to node 40, so this dimension. It is not lost. It is transmitted 3 times, this hop, this hop, and this hop, and it has this latency of is in milliseconds, so of 15 seconds. In some situation, you see that there are more transmissions because in some of this link there is a packet that is lost, so is retransmitted by the simulator. Actually, if you want to add statistics, modify the simulator and so on, since it is easy, it is wide documented, and the code is easy, you can directly modify the Python code in order to obtain all the statistics you want. So, thank you very much for your attention. For any question, feel free to contact me with the channel you prefer. We are working on this simulator. We are preparing a new version of the simulation that is more well documented. It has more features and so on, and we plan to publish it in the next year. Thank you very much.